Well, hey there, kiddos. Welcome to your video on Introduction to Systems. All we're going to do is get introduced to what a system of equations is, what it looks like, and how to determine how many solutions something has, and whether or not a point is a solution. So that's what we're going to do. So there's three types of systems that we're going to talk about. The first type is just simply an intersecting system. And so that basically just means that we have two lines that are going to intersect. They don't have to be perpendicular, they just have to cross and they have to meet in one point. And if that happens, you have a set of intersecting lines, then you have one solution. The thing to know about lines that have one solution is that they are going to have different slopes. If their slopes are different, they will intersect for sure. And so they will have one solution. Another type of system is a parallel system where the lines never ever cross one another. So you have two lines that run side by side. And if you'll remember from when we talked about slope, parallel lines have the same slope, but different y-intercepts, but they have the same slope, and since they never ever cross, then they have no solution because they're never going to touch each other. The third type of system is what we call a coincident system. Not like a coincidence that happens, but coincident system. Sometimes it's also pronounced coincident. You might hear it one of both ways. But what that means is that I have the same exact line. And so I have drawn the line twice, once on top of itself. And so when that happens, you have the same exact equation because they're the exact same line, so you end up with the same equation. And when that happens, you've drawn one line right on top of another line, and so they intersect everywhere because they touch everywhere. And so what you end up with is infinite solutions. As you have an infinite number of numbers that will work and make this a solution. So now let's talk about how to figure out how many solutions a system has. So the next three questions, all we're going to do is look at the slope of the lines. If I have different slopes, I'm going to have one solution. If I have the same slope, I should have no solution. And if I have the exact same equation, then I have infinite solutions. So if you look at number 2 here, this first equation, it's very easy. It's in slope-intercept form. I've got y equals 2x, so the slope is 2. And this equation is y equals 1/2 x minus 3, so the slope of this is 1/2. So they have different slopes, which means I'm going to have one solution. If I were to graph these on my calculator, you'd see that these two lines intersect one another. Now the next problem, the first equation is solved for y already. It says y equals 5x, so I know the slope is 5. This problem down here, the second equation, says 1/5 y equals x plus 7. Well, y is not by itself, so I'm going to multiply both sides by 5 to make that happen. And when I do, I end up with y is equal to 5x plus 35 because I had to multiply everything by 5. So the slope of that line is also 5. So they have the same slope, but the equations are different because I've got 5x and 5x plus 35, which means that I have no solution. This one has none because these will be parallel lines. They have the same slope, different y-intercepts. So number 4, first thing I've got to do is get y by itself. So I'm going to have to add 3x to both sides here. So I'm going to end up with y is equal to 3x minus 1. And so the slope is 3. And this bottom one, I'm going to have to divide everything by 6. And I end up with y is equal to 18 divided by 6 makes 3x. And 6 divided by 6 is 1. So I have y equals 3x minus 1. The slope again is 3. So I have the same slope this time, but if you look at my two equations, they are identical. 3x minus 1, 3x minus 1. This means I have infinite solutions because these are the same line. So that's how you tell. Solve for y, find the slope, compare them, and then you will know how many solutions that the system has. So now let's talk about whether or not a point is a solution. There are 3 more questions here. We're going to do one of them, maybe 2 of them, and then we'll fill in the conclusion. So for number 5, I've got a point, 5, 2, and I want to know if it's a solution to the system. Well, the easiest way to do this is to take these numbers and plug them in. So I'm going to plug in 5 for x and 2 for y. So I have 2/5 times 5 minus 2, and it needs to equal 0. Well, when I do 2 fifths times 5, the 5's cancel. So I end up with 2 minus 2. So that 0 is equal to 0. So yes, it works for this one. But now I have to check and see if it works for this one. So now I have to do 3 times 5 minus 2, and it needs to equal 13. Well, I'm going to pick up my calculator, and I'm going to do 3 times 5 minus 2 and see what it says. And it definitely says that this is 13, so 13 does equal 13. So the point also works when I plug it into this equation. So yes, this one is a solution. So now let's try number 6. Here's my point, negative 2, 2. So I'm going to plug in negative 2 for x, so I've got negative 2 plus 3 times 2, and it needs to equal 4. Again, I'm going to grab my calculator and type that in. And when I do negative 2 plus 3 times 2, I definitely get 4 is equal to 4. So the point works for that equation. Now let's check this other one. The bottom equation, my x already has a negative on it. So when I plug a negative 2 into a negative x, the two negatives cancel and make a positive. So I have 2 plus 2 has to equal 2. Well, last time I checked, 2 plus 2 was 4. And 4 does not equal 2. Since the point doesn't work for this system, it only works for one of them, not both of them, then no, it is not a solution. So if you want to try number 7 just for the practice, plug the points in and make sure that it makes both equations true. As long as it makes both equations true, then it's a solution. So our conclusion really quick. So a single line, you have a line, even if you graph that line twice, once on top of itself, then you have infinite solutions, just like we saw in our example. And two lines can either have one solution because they intersect, or no solution because they are parallel. Two lines have one solution whenever the lines intersect, and two lines have no solution when the two lines are parallel. So there's a question here at the bottom I want you to think about. It says, can you think of a situation into which two lines would have infinitely many solutions? Well, we've already talked about that, so hopefully you can think of that solution. So if you can think of a situation where two lines would have infinitely many solutions, what would it look like if I graphed those two lines? Draw me a picture. You can bring it in when you come to class tomorrow. I will see you then. Have a good rest of your day.